Hold your hand up in front of your face. Keep it still. It looks solid, doesn't it? It feels permanent. The skin seems continuous. The muscles respond to your will, and the heat radiating from your palm feels like a guarantee of life. But you're deceiving yourself. Inside that hand, trillions of atoms are vibrating in a violent, chaotic dance. They are held together by forces so precisely balanced, so terrifyingly specific, that if the strength of the electromagnetic force changed by a fraction of a percent, your hand would not just break, it would explode with the force of a nuclear bomb. You are not a solid object. You are a walking minefield of energy, kept from detonating by a mathematical code that no one can explain. We go through our lives assuming that the ground beneath our feet is stable and that the sun will rise tomorrow. We trust the laws of physics because they seem consistent. But when we actually look at the numbers defining those laws, that trust begins to crumble. The universe operates on a set of fundamental constants, numbers that dictate the strength of gravity, the weight of an electron, and the speed of light. If you were to construct a universe from scratch, and you chose these numbers at random, you would fail every single time. If the strong nuclear force were just 2% stronger, hydrogen would fuse into helium so instantly that every star in the cosmos would explode billions of years ago, leaving nothing but a cold, dark void. If it were 5% weaker, hydrogen would never fuse at all, and the universe would be a sterile sea of gas with no stars, no heat, and no light. We are balancing on a razor's edge. The probability of a universe having the exact conditions necessary for your existence is roughly 1 in 10 to the power of 60. To visualize this, imagine taking a sharp pencil and standing it on its tip on a table. That is difficult, but possible. Now imagine standing that pencil on its tip, but doing it in the middle of a hurricane while an earthquake is shaking the room and having it remain perfectly upright for 14 billion years. That is the level of precision we are talking about. This phenomenon is known as the fine-tuning problem, and it is the single most disturbing discovery in the history of cosmology. It suggests that the universe is not a chaotic, random place, but a rigidly structured mechanism where the slightest error would result in total annihilation. We are not living in a standard universe, we are living in a statistical anomaly, a glitch in the probability that allows complexity to exist for a brief, fleeting moment. And the deeper we look, the more it seems that this anomaly was not an accident. The calibration is too perfect. The pencil is standing too still. And we are left with the chilling realization that we might be walking through a reality that was rigged from the very beginning. If the precarious balance of atomic forces makes you uneasy, consider the empty space between them. We usually think of a vacuum as nothing, a void where nothing exists and nothing happens. But quantum mechanics reveals that this is a lie. Empty space is not empty. It is seething with temporary particles that pop into existence and vanish in nanoseconds. A foaming sea of energy known as the quantum vacuum. According to our best theories, this energy should have weight. It should exert a gravitational push. And when physicists calculate how much energy should be in the vacuum of space, they get a number that is colossal. This energy, known as the cosmological constant or lambda, is responsible for the expansion of the universe. It is the force pushing the galaxies apart. But here is where the nightmare begins. When theoretical physicists use quantum field theory to predict the value of lambda, they calculate a number that is 10 to the power of 120 times larger than what we actually observe. That is a 1 followed by 120 zeros. It is the largest mismatch between theory and observation in the entire history of science. It is not just an error, it is a catastrophe. If the dark energy of the vacuum were actually as strong as the equations suggest it should be, the universe would have torn itself apart in the first fraction of a microsecond. The expansion would have been so violent that no atoms could have formed, let alone stars or galaxies. Every single particle would have been ripped away from every other particle, leaving a cosmos of absolute lonely isolation. On the other hand, if the value were slightly negative, the universe would have collapsed back in on itself. crushing everything into a singularity instantly. Yet, we're here. The value of the cosmological constant is incredibly small, almost zero, but not exactly zero. It is tuned to the one specific value that allows structures to form and life to exist. Imagine you were defusing a nuclear bomb. The timer is counting down, and there is a dial that determines the explosive yield. The dial goes from 0 to 1,000,000,000,000. To save the city, you have to turn the dial to exactly one specific number, say 749, and if you're off by a single notch in either direction, the bomb detonates. And somehow, blindly, without seeing the numbers, the universe landed exactly on the safe zone. This creates a sensation of profound dread. It implies that the vacuum of space, the very medium we move through, is a loaded weapon. The energy density required to obliterate us is theoretically there, sitting in every cubic centimeter of air, but for some reason, it has been cancelled out. It has been neutralized by some unknown mechanism to a precision that defies human comprehension. Why didn't the mine explode? Why is the vacuum quiet? This discrepancy haunts physicists. It suggests that our understanding of reality is fundamentally broken, or that there is a suppression mechanism at work, a rule or a force we have not yet discovered that is keeping the vacuum tame. It forces us to ask if the universe is artificially stabilized, like a nuclear reactor where the control rods are inserted just enough to keep the reaction going without causing a meltdown. We are living inside the reactor, enjoying the warmth, blissfully unaware that the physics governing the fuel rods suggests we should have been vaporized billions of years ago. The silence of the vacuum is not peaceful. It is suspicious. It is the silence of a held breath. When faced with these impossible numbers, the human mind tends to retreat to a simple, comforting defense. Well, we got lucky. We tell ourselves that in an infinite timeline, strange things happen, and we just happen to win the lottery. But this reasoning is intellectually lazy and dangerous. There is a difference between winning a lottery and surviving an execution. And to understand why the luck argument fails, we must turn to a terrifying thought experiment proposed by the philosopher John Leslie, known as the firing squad analogy. Imagine you have been sentenced to death. You are blindfolded and tied to a post. In front of you stand 50 expert marksmen, each armed with a high-precision rifle. They are aiming at your chest from 10 paces away. You hear the order to fire. You hear the deafening crack of 50 rifles discharging simultaneously. You wince, expecting the end. But you feel nothing. You open your eyes and look down. You're unharmed. Behind you, the wall is riddled with 50 bullet holes, forming a perfect outline around your body. Not a single bullet touched you. Now, in this scenario, would your first thought be, wow, what a lucky coincidence? Would you shrug your shoulders and walk away, thinking that the marksman just happened to sneeze at the exact same moment? No. The rational conclusion, the only logical conclusion, is that the execution was rigged. Someone gave the order to miss. The probability of 50 experts missing a target by chance is so astronomically low that it effectively does not exist. The event demands an explanation. It implies intent. It implies a plan. The universe we inhabit is exactly like that survivor. The 50 marksmen are the 50 fundamental constants of nature: gravity, electromagnetism, the mass of the proton, the decay rate of the neutron, and so on. Each one of them had the potential to kill the universe in its crib. If gravity had been slightly stronger, the universe would have collapsed before life began. If the neutron was slightly heavier, atoms would not form. Bullet after bullet was fired at the possibility of our existence, and every single one missed. To claim that this is just random chance is to deny the evidence staring us in the face. It is an act of willful blindness. We are standing in front of the firing squad, breathing the smoke from their rifles and pretending that nothing strange has happened. This realization shifts our perspective from gratitude to suspicion. If the universe was rigged to let us survive, then who rigged it? And more importantly, why? Usually, when an execution is faked, it is because the prisoner is valuable, or because the prisoner is being saved for a different, perhaps darker purpose. We are not just survivors of a cosmic accident. We are the beneficiaries of a highly specific set of initial conditions that seem designed to keep us alive against all odds. This is not a comforting thought. It removes the safety of randomness. If the universe is random, then our death would be meaningless. But if the universe is rigged, then our lives and our eventual deaths might be part of a script we haven't read. We are walking through a world that has been sanitized for our protection, and that raises the most unsettling question of all. What is the architect hiding from us? Why was it so important that we survived the firing squad? So, we are left standing against the wall, unharmed by the firing squad of physics. The smoke clears, and we are forced to ask the single most important question in human existence. Who or what calibrated the rifles? This question is not merely philosophical, it is the central engine of modern cosmology. When we look at the impossible precision of the universe, the fine-tuning of gravity, the specific weight of the electron, the exact energy of the vacuum, we are seeing the fingerprint of an influence we cannot see. We call this entity, or this mechanism, the silent architect. For centuries, humanity has tried to give this architect a name. We have built cathedrals to it, written equations for it, and argued wars over it. But if we strip away the mythology and look strictly at the logic of the situation, there are really only three possibilities. Three distinct paths that could explain why the universe is so perfectly constructed for our existence. The first possibility is that the architect is chance, blind, dumb, infinite luck. This implies that we are not the only universe, but merely one bubble in a boiling ocean of trillions of dead, broken worlds. We are the survivors of a cosmic massacre, standing on a mountain of corpses, mistaking our survival for importance. The second possibility is that the architect is a purpose, a force, an intelligence, or a principle that intended for us to be here. This does not necessarily mean a bearded man in the sky. It could be a super advanced civilization running a simulation, a self-correcting biological system, or a rigid geometric law that mandates complexity. The third possibility, and perhaps the most unsettling one, is that the architect is us. That we are trapped in a strange loop of causality where our own existence in the future somehow dictates the conditions of the past. In this video, we are going to explore these possibilities, peeling them back layer by layer. We will not look for a simple answer. We are going to look for the structural flaws in reality that betray the true nature of the architect. We will move from the microscopic weirdness of the quantum world to the macroscopic horror of the multiverse, and finally to the cold thermodynamics of the end of time. And we will start with the explanation that scientists hate the most, yet rely on the most. The idea that the question itself is a trap. Before we can accept any of these radical theories, we must confront the standard answer that science offers to the problem of fine-tuning. It is called the Anthropic Principle, and it is infuriatingly simple. It states, in essence, we observe the universe to be fine-tuned for life, because if it were not fine-tuned for life, we would not be here to observe it. At first glance, this sounds logical. It is like saying, why did I survive the plane crash? Because if I hadn't, I wouldn't be asking why I survived. It is undeniably true, but it explains absolutely nothing about why the plane crashed, or why you were the one to walk away. It is a tautology, a circular argument that uses the result to explain the cause. It treats our existence as a brute fact that requires no further investigation. Imagine a puddle of water waking up one morning in a hole in the ground. The puddle looks around and thinks, this is an interesting world I find myself in, an interesting hole. It fits me rather neatly, doesn't it? In fact, it fits me staggeringly well. Must have been made to have me in it. This famous analogy by Douglas Adams highlights the arrogance of the Anthropic Principle. The puddle thinks the hole was designed for it, when in reality, the puddle simply took the shape of the hole. The Anthropic Principle suggests that we should not be surprised by the precision of the universe, because we are the sample bias. But this answer feels hollow. It feels like a surrender. It tells us to stop asking questions and just accept the miracle. But the human mind cannot accept a miracle without a mechanism. If the hole fits the puddle perfectly, we want to know who dug the hole. If the constants of nature are dialed into the 120th decimal place, because we are here is not an answer. It is an excuse. It is a way of sweeping the mystery under the rug of our own existence. We need a mechanism. We need a cause. And if we reject the idea that this is just a brute fact, we must look for an active agent. And the first place we must look is in the mirror. This brings us to our first major theory, and it requires us to abandon our common sense entirely. What if the universe wasn't fine-tuned for us? What if it was fine-tuned by us? This sounds like pure solipsism, the ravings of a madman who thinks the world disappears when he closes his eyes. But in the realm of quantum mechanics, this idea is a serious scientific hypothesis proposed by one of the greatest physicists of the 20th century, John Archibald Wheeler. Wheeler coined the term the Participatory Universe. He argued that the universe is not a machine that runs on its own, independent of us. Instead, he suggested that the act of observation is a fundamental building block of creation. In the classical world of Isaac Newton, a tree falls in the forest regardless of whether anyone hears it. But in the quantum world, things are not so defined. Before a particle is measured, it does not exist in a specific place. It exists as a wave of probability, a ghostly cloud of could be and might be. It is only when an observer interacts with it, when a measurement is made, that the wave collapses into a solid particle. This means that the observer is not just a passive audience member watching the cosmic play. The observer is the director. Wheeler famously drew a diagram to explain this. A large letter U representing the universe. One arm of the U starts at the Big Bang and evolves over billions of years, growing galaxies and stars. At the end of the other arm is an I, us. The I is looking back at the beginning of the U. Wheeler suggested that by looking back, by observing the cosmos, we are the ones bringing the Big Bang into reality. This theory implies that the silent architect we have been looking for is consciousness itself. The constants of nature are perfect because we are the ones measuring them, and our measurement forces them to settle into a state that allows us to exist. It suggests a loop in time where the future creates the past. We are not the children of the universe, we are its parents, reaching back through time to sculpt the conditions of our own birth. It is a concept of staggering power, granting humanity a role that borders on the divine. But can a look really change physical history? As it turns out, we have proof that it can. To prove that the observer can affect the past, physicists devised an experiment that breaks the linear flow of time. It is known as the delayed choice experiment, and its results are so disturbing that they challenge the very definition of history. It starts with the famous double slit experiment. When you fire photons, particles of light, at a screen with two slits, they behave in a strange way. If you don't watch them, they act like waves, passing through both slits at once and creating an interference pattern. If you do watch them, they act like particles, choosing one slit or the other. The act of looking forces the photon to decide its path. But Wheeler asked a darker question. What happens if we wait to look until after the photon has already passed through the slits? Imagine a photon traveling from a distant star, billions of light years away. On its journey to Earth, it encounters a galaxy that acts as a gravitational lens, offering the photon two possible paths to reach us. Path A, left, or path B, right. According to the quantum mechanics, until the photon is measured, it takes both paths simultaneously as a wave. It travels for billions of years in this undecided state. Finally, it arrives at Earth and enters a telescope. Here is the twist. You, the observer in the present day, have a choice. You can choose to measure which path the photon took, particle mode, or you can choose to measure the interference pattern, wave mode. Logic dictates that the photon must have decided whether to be a wave or a particle billions of years ago, when it passed the galaxy. But the experiment shows the opposite. The nature of the photon, whether it took one path or both, is determined by the measurement you make today. If you choose to look for a particle, the photon effectively says, I took path A billions of years ago. If you choose to look for a wave, the photon says, I took both paths billions of years ago. Your choice in the present reaches back across the eons and rewrites the history of that particle. The future event, your observation, causes the past event, the path taken. This is not a theoretical abstraction. This has been confirmed in laboratories using lasers and mirrors. It proves that the history of the universe is not a fixed stone tablet. It is a fluid, shifting narrative that only solidifies when it is read. If we apply this to the Big Bang, the implication is shattering. It suggests that by observing the cosmic microwave background radiation today, we are actively crystallizing the physics of the early universe. We are tuning the radio of reality to the station that plays our song, retroactively ensuring that the Big Bang happened in the exact specific way required to produce us. We are the architects of our own history, trapped in a timeline that we are writing as we live it. If the delayed choice experiment holds true for a single particle of light, then it must hold true for every particle in the universe. This means that the history of the cosmos is not a solid timeline that stretches back 14 billion years. It is a cloud of probability that only crystallized when the first eyes opened to see it. Before life evolved, the universe was in a state of superposition, a chaotic mix of every possible reality where gravity was too strong or too weak, and where atoms formed or failed to form. It was a blur of potential futures waiting for a judge. When the first conscious observer looked up at the sky, that act of observation sent a shockwave backward through time. It collapsed the wave function of the entire universe, forcing it to choose a specific history. And naturally, the history that was chosen was the only one that led to the existence of the observer. We are not merely inhabitants of this reality. We are the tuning mechanism. By simply existing and perceiving the world, we have retroactively adjusted the dials of the Big Bang, ensuring that the fundamental constants settled into the precise values required for carbon and water and life. This idea transforms the fine-tuning problem from a mystery into a necessity. The universe is perfect because we are looking at it. If we were not here to look, the universe would not be fine-tuned. In fact, it would not be anything at all. It would remain a ghost. This suggests that humanity is not a cosmic accident appearing on a lonely rock in the middle of nowhere. It suggests that we are the linchpin of existence, the anchor that holds the past in place. Without us, the stars would dissolve back into a fog of quantum uncertainty. We are the architects who built the house simply by waking up inside it. This line of reasoning leads us to a radical philosophy known as biocentrism, championed by the scientist Robert Lanza. Biocentrism flips the standard model of science on its head. Usually we assume that the universe is a physical object that exists out there, and that life is just a biological accident that happened to grow on its surface. But biocentrism argues that biology and consciousness are the fundamental reality and that the physical universe is created by the mind. Consider the color blue. A photon of light has a wavelength of 470 nanometers. It has an energy and a frequency, but it does not have a color. The sensation of blue exists only in your brain. It is a translation code created by your consciousness to make sense of the data. Without an eye and a mind, there is no blue. There is only silent radiation. Lanza argues that space and time are exactly the same. They are not external objects. They are the software tools our mind uses to organize information. If space and time are tools of the mind, then the fine-tuning of the universe is an illusion. The universe appears to be designed for life because it is a projection of life. It is like a biological glove that fits our hand perfectly because our hand created the shape of the glove. We are not living in a Goldilocks zone that was prepared for us. We are projecting a Goldilocks reality outward from our own minds. This solves the mystery of the constants but it traps us in a terrifying form of loneliness. It implies that the cold vastness of space, the burning stars, and the swirling galaxies are all happening inside our collective head. We are the dreamers of the dream, and if we were to wake up, the universe would vanish. But this godlike power comes with a devastating logical price. If we argue that the observer created the universe, then we are immediately faced with the bootstrap paradox. This is the impossible loop of a snake eating its own tail. To create the universe, you need an observer. But to get an observer, you need a universe where that observer can evolve. It takes billions of years of stellar evolution to create the carbon needed for a brain. It takes stable gravity and electromagnetism to allow that brain to function. If those laws did not exist before the observer, then the observer could never have evolved to look back and create the laws. You cannot lift yourself up by pulling on your own shoelaces. This is a logical short circuit. It suggests that the cause and the effect are hopelessly tangled. If we rely on the quantum observer theory, we are saying that the universe is a self-causing loop that hangs in the void supported by nothing. It is a story that writes itself. But in our experience, information must come from somewhere. A child needs a parent. A building needs a foundation. The idea that we are the creators of reality satisfies our ego, but it breaks our logic. It feels like a magic trick where the magician pulls a rabbit out of a hat, but the rabbit is also the magician. This paradox forces us to look for a way out. If human consciousness is too recent to have created the Big Bang, then perhaps the observer is not us. Perhaps there was something else watching the universe long before the first human opened their eyes. Someone or something that collapsed the wave function and set the stage for our arrival. There is a darker emotional problem with the idea that we are the creators of reality. If the universe is a projection of our consciousness or a product of our observation, why is it so incredibly hostile to us? If you were dreaming a world into existence, would you fill it with black holes that can swallow you whole? Would you invent cancer and viruses that destroy your body from the inside? Would you design a cosmos where 99% of the volume is a freezing radiation-filled vacuum that would kill you in seconds? The theory of the participatory universe implies that we have agency, that we are the masters of the house. But our daily experience tells us that we are victims of the house. We are fragile biological machines, constantly fighting against the laws of physics just to stay alive. Gravity drags us down. Entropy rots our cells. The sun burns our skin. If we subconsciously designed this place, we have a masochistic streak that is terrifying to behold. This contradiction leads to a sensation of profound fear. It suggests that while the universe requires an observer, that observer might not be us. We might simply be the characters trapped inside a story that is being read by someone else. The fact that we feel pain and the fact that the universe resists our will proves that reality is external. It is hard, it is sharp, and it does not care about us. We are not the dreamers, we are the dream. And this realization forces us to look outward. If the loop of self-creation is impossible, and if we are too weak to be the architects, then there must be another set of eyes in the room. An observer who was here long before the first human evolved. If we accept the logic of quantum mechanics that a system remains in a state of chaotic probability until it is observed, then the early universe presents a massive problem. For billions of years before life began, galaxies were forming and stars were burning. Who was looking at them? Who collapsed their wave functions to make them real? The standard answer is that the universe evolved blindly until we arrived. But as we have seen, this leads to the grandfather paradox of us creating the conditions for our own birth. To break this loop, we need an observer who stands outside the system, an entity that is not part of our timeline and not subject to our limitations. In the religious texts, this role is filled by a god, a being who sees all and thereby maintains the existence of all. But in the language of modern science and probability, we do not need a supernatural deity to fulfill this role. We simply need a level of complexity that is higher than our own. Imagine a fish in an aquarium. It sees the glass walls. It sees the perfectly regulated temperature of the water. It sees the food falling from the surface at regular intervals. To the fish, the environment is fine-tuned for its existence. It might think it created this paradise or that the universe is just naturally benevolent. But the fish is wrong. The aquarium is maintained by a human, standing outside the glass looking in. The human is the observer who collapses the reality of the tank. This brings us to the second terrifying possibility of the silent architect. What if our universe is just a tank? And what if the fine-tuning is not a miracle, but a setting on a thermostat controlled by something else? This leads us directly to one of the most famous unsolved mysteries in science, known as the Fermi Paradox. The universe is 14 billion years old and contains trillions of stars. Mathematics dictates that life should be abundant. We should be seeing signals from other civilizations everywhere. We should see megastructures blocking the light of stars. We should hear radio waves screaming across the sky. But when we point our telescopes at the stars, we hear only static. The silence is absolute. Usually we interpret this silence as a sign that we are alone, or that civilizations destroy themselves before they can travel the stars. But in the context of the fine-tuning problem, the silence takes on a sinister new meaning. If you are running a controlled experiment, you do not let the test subjects interact with the outside world. You isolate them. You sterilize the environment to prevent contamination. The hypothesis of the zoo or the Petri dish suggests that the reason we see no aliens is that we are in a quarantine zone. The universe looks empty because it has been scrubbed clean for us. The fine-tuning of the physical laws is the artificial environment created to sustain the colony. Just as a scientist carefully adjusts the pH levels and the temperature in a Petri dish to grow a specific type of bacteria, the constants of our universe have been tweaked to grow intelligent life. We are not the masters of space, we are the mold growing on the gel, and the reason we haven't met the owners of the lab is that bacteria are not supposed to talk to the scientists. To understand who could build such a cage, we must look at the Kardashev scale. This is a method used by astrophysicists to classify civilizations based on their energy consumption. A Type 1 civilization can use all the energy on their planet. We are not even Type 1 yet. A Type 2 civilization can harness the entire energy of their star. A Type 3 civilization controls their entire galaxy. But theoretical physics allows for a Type 4 civilization. A society so advanced that they can harness the energy of the entire universe. Entities operating at this level would be indistinguishable from gods. They would not just build ships or cities. They would build physics. They would have the technology to reach into the fabric of space-time and manipulate the fundamental strings of reality. They could change the mass of an electron or adjust the strength of gravity just as easily as we adjust the brightness of a screen. If such a civilization exists, then the fine-tuning problem vanishes. The universe is perfect because it was engineered to be perfect. The constants of nature are not random numbers. They are the coordinates entered into a machine. This theory explains everything. It explains why the math is so elegant. It explains why the conditions are so stable. And it explains why we are alone. We are a project. Perhaps we are a simulation of their own past. Or perhaps we are a weapon being grown in a safe harbor. But the most frightening implication of the Type 4 theory is not that they are powerful. It is that they are experimenters. And in science, an experiment is only useful as long as it provides data. To truly feel the weight of the laboratory hypothesis, we must look at the specific dials that have been adjusted. The most famous and unsettling example of this is the existence of carbon. Carbon is the backbone of all life as we know it. Your muscles, your brain, and your DNA are all built from carbon chains. But carbon is incredibly difficult to make. In the early universe, after the Big Bang, there was only hydrogen and helium. Heavier elements like carbon had to be forged inside the nuclear furnaces of stars. For decades, physicists could not understand how stars managed to do this. The process requires 3 helium nuclei to collide and fuse together simultaneously. This is known as the triple alpha process. Statistically, this collision is extremely unlikely. It is like throwing 3 darts at a board and having them all hit the exact same point at the exact same millisecond. In a random universe, this should almost never happen. If it did not happen, the universe would be devoid of carbon and therefore devoid of life. In the 1950s, the astrophysicist Fred Hoyle looked at this problem and realized that for carbon to form, there had to be a specific energy resonance, a precise level of vibration in the carbon nucleus that exactly matched the combined energy of the 3 helium nuclei. He calculated what this energy level had to be. It was 7.65 million electron volts. When experimentalists went into the lab to check, they found the level was exactly 7.65 million electron volts. Hoyle was so shaken by this discovery that he stated that his atheism was greatly shaken. He wrote that a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking of in nature. This resonance does not look natural. It looks like a preset frequency. Imagine a radio that only picks up one station because the internal crystal has been ground to a microscopic precision to capture exactly that wavelength. The carbon atom is that radio, and it is tuned to the frequency of life. If the nuclear force were changed by less than 0.5%, this resonance would disappear. The stars would stop producing carbon. The universe would remain a sterile mix of gas. This suggests that the laws of nuclear physics were deliberately designed with the end goal of producing biological matter. We are not just living in a universe that allows life. We are living in a universe that bends over backward against the odds to force life into existence. This realization strips us of our dignity. We are not free agents wandering a wild cosmos. We are the intended product of an industrial process. If the physics of stars provides the hardware for the experiment, then biology provides the software. And when we look at the code of life known as DNA, we find features that are deeply unsettling. The genetic code is universal. Every living thing on Earth, from a bacteria to a blue whale, uses the exact same dictionary to translate chemical sequences into proteins. This code appeared very early in the history of the Earth, almost as soon as the planet cooled down enough to support liquid water. The Nobel Prize winner Francis Crick, one of the discoverers of the DNA structure, proposed a theory called directed panspermia. He argued that the complexity of the DNA molecule is so high that it is difficult to see how it could have evolved naturally in the short time available on the early Earth. He suggested that the seeds of life might have been deliberately sent here by an advanced civilization, a package of biological starter material fired across the galaxy to colonize sterile worlds. If this is true, then our DNA is not a product of random mutation, but a piece of alien technology that has been replicating and upgrading itself for 4 billion years. But the anomalies are not just microscopic, they are also macroscopic. Consider the total solar eclipse. This is a phenomenon where the moon passes in front of the sun and blocks it out perfectly, completely covering the solar disk while leaving the corona visible. For this to happen, 2 numbers must align perfectly. The sun is 400 times larger than the moon, but the sun is also exactly 400 times farther away from Earth than the moon. This geometric coincidence makes them appear exactly the same size in our sky. Astronomers admit that there is no physical reason for this ratio to exist. It serves no gravitational purpose. It does not help the orbital stability. In the vast majority of planetary systems, eclipses are messy. The moon is either too small and passes like a dot, or too big and blocks out everything. Earth is the only known planet where this perfect fit occurs. And crucially, we are the only observers capable of appreciating it. It feels like an Easter egg in a video game. A little nod from the designers. A stylistic flourish left to impress the inhabitants of the cage. These coincidences give us the creeping sensation of the uncanny valley. The feeling that things are too neat, too symmetrical, and too staged to be real. It is the feeling of walking through a movie set and realizing that the trees are made of plastic and the sky is painted on a wall. The idea that we are a chosen experiment or a protected species in a zoo might seem comforting at first. It implies that we are valuable. It implies that there are higher beings who care about our existence enough to tweak the stars and send us DNA. But anyone who has ever worked in a laboratory knows the dark truth about experiments. They do not last forever. An experiment is run to answer a specific question. Once the question is answered, the experiment is over. If the universe is a simulation or a physical testbed designed by a Type 4 civilization, then we are living on borrowed time. We do not know what the parameters of the test are. Perhaps they are running a simulation to see how long a civilization can survive without destroying itself with nuclear weapons. Perhaps they are testing the evolution of consciousness. Or perhaps they are simply growing us to harvest something we cannot even comprehend, like art or novelty or data. But what happens when the data is collected? What happens when the simulation reaches its conclusion? The scientists turn off the machine, they bleach the petri dish, they reformat the hard drive to make room for the next run. This leads to a source of existential anxiety that is far sharper than the fear of natural death. It is the fear of the cancel button. In physics, there is a theoretical catastrophe known as vacuum decay, where a bubble of lower energy physics appears and expands at the speed of light, destroying everything in its path. We usually view this as a natural disaster. But in the context of the laboratory hypothesis, vacuum decay looks suspiciously like a system shut down. A formatting wave sent to wipe the slate clean. If we are an experiment, then our greatest threat is not an asteroid or a plague. It is the possibility that we might become boring. If we stop producing interesting data, or if we solve the puzzle we were created to solve, the lights might simply go out. This turns our history into a performance. We are dancing for an invisible audience, terrified that if we stop, the applause will end and the theatre will be demolished. However, as terrifying as the laboratory hypothesis is, it suffers from a fatal logical flaw. It kicks the can down the road without actually solving the mystery of existence. If we argue that our universe is fine-tuned because it was built by a super advanced alien civilization, then we must immediately ask who built the universe that the aliens live in. For a Type 4 civilization to exist, and to have the complexity required to build universes, they must inhabit a reality that allows for complexity. Their universe must have stable matter. It must have energy sources. It must have time. This means that their universe must also be fine-tuned. Did they have a creator too? Is there a super civilization above them? This leads to an infinite regress, a ladder of creators going up forever with no bottom rung. The biologist Richard Dawkins uses this argument to dismantle the idea of intelligent design. He argues that any being capable of designing a complex universe must be even more complex than the universe it designs. Therefore, the designer is even more improbable than the creation. Explaining a fine-tuned universe by invoking a fine-tuned creator explains nothing. It just multiplies the mystery. We are looking for the bedrock of reality. We are looking for the fundamental reason why order exists. And a laboratory is not a fundamental thing. It is a constructed thing. To find the true answer, we must stop looking for people, whether they are gods or aliens, and start looking at the structure of the reality itself. We need to look at the walls of the cage, not the zookeepers. If we zoom in on the fabric of space-time past the atoms, past the nucleus, and past the quarks, we eventually hit a barrier. A limit where the smooth continuity of the world breaks down and reveals that the universe is not made of matter at all. It is made of pixels. And this discovery leads us from the paranoia of the zoo to the vertigo of the hologram. When we look at a digital photograph on a screen, it appears to be a smooth, continuous image. You see the curve of a face or the gradient of a sunset. But if you take a magnifying glass and zoom in eventually, the smoothness vanishes. You see a grid of square blocks, pixels, individual units of color that cannot be divided any further. This pixelation is the proof that the image is not a physical object, but a collection of data. For centuries, physicists believed that space was smooth. They thought you could divide a meter into a centimeter and a centimeter into a millimeter and keep dividing forever. But quantum mechanics revealed that this is impossible. There is a smallest possible unit of distance known as the Planck length. It is roughly 10 to the power of minus 35 meters. A decimal point followed by 34 zeros, and then a 1. This is a scale so small that if a single atom were magnified to the size of the observable universe, the Planck length would be the size of a tree. The existence of the Planck length implies that our universe is pixelated. You cannot move a distance smaller than this unit. It is the resolution limit of our reality. When we hit this floor, the laws of geometry break down. The concept of location becomes fuzzy. This suggests that the universe has a finite bandwidth. It can only hold a certain amount of information in a certain amount of space. This is exactly how a computer simulation or a hologram works. It has a resolution limit determined by the processing power or the storage density of the medium. This discovery moves us away from the idea of biological aliens and toward the idea of mathematical structure. If the universe creates space out of discrete bits of information, then fine-tuning is not about setting dials on a machine. It is about the efficiency of the code. We are entering the realm of the holographic principle, where the three-dimensional world we think we live in is exposed as a grand optical illusion projected from a distant surface. The walls of our cell are not made of glass. They are made of data. To understand why the universe might be a hologram, we must first look at the most destructive objects in the cosmos: black holes. For decades, physicists believed that black holes were simply trash cans of reality, places where matter and energy fell in and vanished forever, crushed into a singularity where the laws of physics ceased to exist. But in the 1970s, Stephen Hawking discovered a paradox that threatened to destroy the very foundations of science. He realized that black holes are not truly black. They emit a faint glow of radiation now known as Hawking radiation. This radiation carries energy away from the black hole, causing it to slowly shrink and eventually disappear completely. Here is the problem. In quantum mechanics, there is a sacred rule called unitarity. It states that information can never be destroyed. If you burn a book, you can theoretically reconstruct the text from the ash and the smoke if you track every single particle. The information is scrambled, but it is still there. But Hawking calculated that the radiation leaving a black hole is random. It carries no record of what fell inside. If the black hole evaporates completely and the radiation is blank, then the information of everything that fell into it is erased from existence. This is not just a loss of history. It is a violation of the basic logic of cause and effect. If the past can be deleted, then the future cannot be predicted. This sparked a 20-year intellectual war between Stephen Hawking and Leonard Susskind. Susskind realized that if Hawking was right, then physics was broken. But if physics was right, then our understanding of space must be wrong. Susskind proposed a radical solution to save the information. He argued that when an object falls into a black hole, its information is not lost in the center. Instead, it is plastered onto the surface of the event horizon. The horizon acts like a two-dimensional shell that stores the data of everything inside, like a sticker on the outside of a suitcase. This means that the three-dimensional object inside the hole is physically linked to a two-dimensional pattern on the surface. The object is effectively a hologram, a projection of the data stored on the shell. This was the first crack in the illusion of depth. It suggested that the volume of space is not where the reality is. The reality is on the walls. The idea that information is stored on the surface of a black hole leads to a concept known as the Bekenstein bound. Jacob Bekenstein realized that the amount of information or entropy a region of space can hold is proportional to its surface area, not its volume. This is completely counterintuitive. Imagine a library. If you want to store more books, you build a bigger room. You increase the volume. If you double the size of the room, you expect to store 8 times as many books. But in the physics of black holes, if you double the size of the room, you only store 4 times as much information because the limit is defined by the walls, not the air inside. If you try to pack more information into a region than the surface area allows, the region will inevitably collapse into a black hole. This means that the maximum resolution of reality is determined by the boundary. Leonard Susskind took this principle and applied it to the entire universe. He argued that if the physics of the most extreme objects, black holes, works this way, then the physics of everything else must work this way too. This is the Holographic Principle. It states that our entire three-dimensional universe, with its galaxies, stars, and vast depths, is mathematically equivalent to a two-dimensional film located at the cosmic horizon. Everything we see and touch is a projection. When you move your hand forward, you think you are moving through deep space. But in reality, you are a pattern of information shifting across a flat, distant surface. The sensation of depth is a mirage. It is like watching a movie in a cinema. The actors on the screen look like they have volume. They look like they are standing behind one another. But if you walk up to the screen and touch it, you feel only a flat sheet. We are the actors in the movie. We are convinced of our own solidity. But we are merely the shadows cast by a light we cannot see playing across the edge of the universe. For many years, the holographic principle was just a fascinating conjecture. A strange idea that philosophers and writers loved, but hard-nosed physicists treated with skepticism. That changed in 1997, when the Argentine physicist Juan Maldacena published what is now the most cited paper in the history of high-energy physics. He discovered a concrete mathematical bridge called the ADS-CFT correspondence. This theory connects two completely different kinds of universes. On one side, you have anti-de Sitter space, or ADS, which is a universe with gravity curvature and 3 spatial dimensions. On the other side, you have conformal field theory, or CFT, which is a quantum universe without gravity that exists in only 2 dimensions on the boundary of the first universe. Maldacena proved that these two worlds are exactly the same. Every single equation describing gravity in the 3-dimensional bulk can be translated into an equation describing quantum particles on the 2-dimensional border. It is like having a dictionary that translates English into Chinese. The stories look completely different. The symbols are different, the grammar is different, but the meaning is identical. If you solve a problem in the 2-dimensional flat world, the answer applies perfectly to the 3-dimensional solid world. This is not a metaphor. It is a rigid mathematical duality. It proves that gravity, which we perceive as a force pulling us down, is actually a holographic effect generated by the interactions of quantum fields on the edge of the cosmos. It implies that the dimension of depth is emergent. It is not fundamental. It pops into existence because of the complexity of the boundary data, just as heat pops into existence from the motion of atoms. This discovery turned the hologram from a ghost story into a textbook reality. We are living inside the projection of a lower dimensional reality, and the math works too well for it to be a coincidence. If the universe is a hologram, then the fine-tuning problem takes on a completely new and digital appearance. In a holographic system, the clarity of the projection depends on the quality of the data transmission. If the data on the boundary is corrupted or noisy, the projection inside the bulk will be blurry or chaotic. This brings us to the work of theoretical physicist James Gates, who made a startling discovery while analyzing the equations of supergravity and string theory. Gates found that buried deep within the mathematical structures describing the fundamental particles are sequences that look identical to binary computer code. Specifically, he found structures that resemble doubly even self-dual linear binary error correcting codes. These are the same types of codes used by computer engineers to ensure that data is transmitted accurately across a noisy channel like the internet or a satellite feed. They are checksums designed to detect and fix glitches. This suggests that the constants of nature, the speed of light, the charge of the electron, and the strength of gravity are not random physical properties. They are the settings of the error correction algorithm. The universe is fine-tuned because if the parameters were off, the data stream would collapse. The hologram would fragment into noise. This view removes the need for a benevolent creator or a lucky accident. It replaces them with the cold logic of information theory. We exist because the code is stable. We are not the purpose of the broadcast. We are simply the image that appears when the signal is clear. The precision of the universe is the precision of a high-definition signal, and we are the pixels that form the picture. If the signal were any weaker, we would dissolve into static. This implies that reality is fragile. It is maintained by a constant stream of information, and if the stream stutters, we vanish. If space is a projection, we must ask what holds the projection together. What keeps the pixels from drifting apart and leaving holes in reality? The answer lies in the strangest phenomenon in quantum mechanics: entanglement. Usually we think of entanglement as a spooky link between two particles where changing one instantly changes the other. But new theories such as the ER equals EPR conjecture proposed by Juan Maldacena and Leonard Susskind suggest that entanglement is far more fundamental. It is the thread that weaves the fabric of space-time itself. According to this view, space is not a pre-existing stage. It is a network of entangled quantum states. The more entangled two regions are, the closer they are in space. If you have a lot of entanglement, you get a smooth, continuous geometry. If you reduce the entanglement, the space begins to stretch and tear. And if you cut the entanglement completely, the space disappears. The two regions become completely disconnected realities with no distance between them, because distance itself has ceased to exist. This idea is known as it from qubit. It suggests that the solid world we walk through is like a sweater knitted from quantum threads. The fine-tuning of the universe is the tension of the knitting. If the tension is too loose, the sweater unravels. If it is too tight, the geometry crumples. We are living on a mesh of information that is constantly being stitched together by quantum correlations. This adds a layer of terrifying fragility to our existence. It means that the void of space is not just empty. It is a constructed bridge, and bridges can collapse. If the quantum entanglement that binds our solar system together were to suddenly disentangle space itself, would evaporate. We would not just die, we would lose the very concept of location. We are suspended over a non-existent abyss, held up only by the invisible threads of quantum connection. If we strip away the illusion of depth and accept the holographic nature of the cosmos, we eventually arrive at a phrase coined by the legendary physicist John Wheeler: it from bit. This is not just a catchy slogan, it is a fundamental manifesto that reverses our understanding of existence. Usually we assume that the it comes first. The rock, the atom, the star, the physical substance is the primary reality. And the bit, the information describing the rock, is secondary. We think information is just a description of a thing. But Wheeler argued the opposite. He claimed that the bit is the bedrock. The universe is fundamentally made of information, and physical objects are merely the way that information manifests to our senses. Imagine playing a game of 20 questions. You're in a room with a group of people, and you have to guess an object. You ask, "Is it alive?" They answer, "No." You ask, "Is it bigger than a toaster?" They answer, "Yes." Bit by bit, answer by answer, a picture forms in your mind. Eventually you narrow it down and say, "Is it a clouded leopard?" And the room says, "Yes." In the classical version of the game, the word leopard was written on a card in someone's pocket before the game started. The object existed before the questions. But Wheeler proposed a quantum version of the game. In this version, there is no card. There is no word in the pocket. When you ask the first question, "Is it alive?" the universe has not decided yet. The players answer randomly, but their answer constrains the future possibilities. If the first answer is no, then the object can never be a leopard. As you ask more questions, the cloud of probability shrinks. The history of the object is created by the interrogation. Finally, when you ask the last question, the object pops into existence. The it, the leopard, is created by the bits, the answers. This suggests that the universe is a system of information processing. Every interaction between particles, every photon hitting an electron, is a yes/no question asked and answered. Are you here? Yes. Do you have spin-up? No. The fine-tuning of the universe, therefore, is not a physical construction project. It is a linguistic consistency. The laws of physics are the grammar of the language. The constants are the vocabulary. We are living in a reality that is being spoken into existence, syllable by syllable. And if the information stops flowing, if the questions stop being asked, the physical world would simply dissolve like a sentence that was never finished. The realization that we are made of bits, projected from a distant holographic boundary, leads to a devastating conclusion about human nature. We cherish the idea of free will. We believe that we are autonomous agents, making choices, shaping our destiny, and moving through the world with purpose. But in a holographic universe, the source of our reality is not here. It is there, on the distant horizon, encoded in a scramble of data that we cannot see and cannot touch. Think about a shadow puppet on a wall. The shadow can move, it can dance, it can interact with other shadows. It might even believe it is alive. But the shadow has no agency. It cannot choose to raise its arm unless the hand casting the shadow moves first. The cause of the movement is located far away from the effect. If we are holographic projections, we are the shadows. The real version of you, the data that defines your existence, is smeared across the edge of the universe, evolving according to the rigid laws of conformal field theory. This disconnect creates a sensation of absolute nihilism. It implies that your thoughts, your loves, and your struggles are merely the playback of a recording. The information on the boundary dictates the projection in the bulk. You are not living your life, you are being broadcast. And just like a movie character cannot turn to the audience and change the plot, you cannot change the script written on the cosmic horizon. Furthermore, this boundary is likely located in the infinite future or the infinite past, depending on how you interpret the geometry. This means that the script might already be finished. We are experiencing the illusion of a flowing narrative, but the data is static. We are ghosts haunting a machine that has already run its course. The light shines through the film, and we dance on the screen, convinced that we are improvised, when in fact every step was mathematically determined before the stars were born. The question, who created the universe, becomes, who filmed the movie? And the answer might be that there is no filmmaker, just an eternal frozen reel of film unwinding in the dark. However, there is one feature of our universe that resists the cold, static description of a hologram or a computer code. A hologram is a fixed image. A code is a set of instructions. But our universe is doing something that machines generally do not do. It is growing. Since the Big Bang, the cosmos has been expanding, stretching the fabric of space-time, pushing galaxies apart, and creating new volumes of nothingness every second. And recently, we discovered that this expansion is accelerating. The universe is getting bigger, faster. If we look at this behavior without the bias of physics, and instead view it through the lens of biology, it looks suspiciously like an organism. A child grows, a cell divides, a population expands to fill its niche. Growth is the signature of life. The fine-tuning of the physical constants, the specific settings that allow for complexity, might not be the code of a simulation or the accidental luck of a survivor. It might be the genetics of a species. If the universe is alive, then the silent architect is not a builder, but a parent. And if the universe is a parent, then it must have a method of reproduction. This thought forces us to pivot from the sterile, digital world of information theory to the messy, violent world of evolutionary biology. We must ask, how does a universe reproduce? Where are its reproductive organs? And does it have predators? The answers to these questions lie in the only objects in the cosmos capable of puncturing the fabric of reality and creating a tunnel to somewhere else. We are going back to black holes, but this time, we are not looking at them as hard drives. We are looking at them as eggs. In the early 90s, the theoretical physicist Lee Smolin proposed a theory that sounds like science fiction, but is grounded in the hard math of general relativity. It is called cosmological natural selection. Smolin looked at the singularity at the center of a black hole, a point of infinite density where space and time are crushed out of existence. Standard physics says this is a dead end, but Smolin suggested that the singularity is actually a door. When a massive star collapses, it squeezes matter down to a point. Smolin argued that instead of vanishing, this matter bounces back. It undergoes a quantum bounce and expands outward again, but it doesn't expand back into our universe. That would be impossible because of the event horizon. Instead, it expands into a new dimension, inflating to create a completely separate baby universe, disconnected from our own. This means that every black hole in our sky, and there are millions of them, is the back of a big bang for another reality. Our universe is not a lonely island. It is a parent, pregnant with billions of offspring. And crucially, our own Big Bang was likely the result of a black hole forming in a previous parent universe. We are living inside the blowout of a collapsed star from a higher dimension. This theory fundamentally changes the emotional texture of the cosmos. It transforms the cold, empty void into a seething, reproducing flesh. The universe becomes a biological entity, a massive, multi-dimensional family tree growing through the bulk of hyperspace. But like any biological system, this process is governed by the laws of inheritance, and this is where the fine-tuning problem finally begins to make sense. We are not designed by a god, we are shaped by the genes of our ancestors. For natural selection to work, you need two things: reproduction and mutation. We have the reproduction, black holes. But where is the mutation? Smolin proposed that when a baby universe is born, the extreme violence of the singularity causes the fundamental constants of physics to shift slightly. The mass of the proton might get a tiny bit heavier. The strength of gravity might get a tiny bit weaker. These are genetic mutations of the physical laws. Most of these mutations are fatal. If the new universe has gravity that is too weak, matter will never clump together to form stars. No stars means no black holes. No black holes means no reproduction. That universe is sterile. It expands forever as a cold, dead gas, leaving no offspring. It is an evolutionary dead end. But occasionally, a mutation occurs that makes the universe better at making stars. Perhaps gravity is tuned just right to crush gas clouds efficiently. This universe will produce billions of stars, and therefore millions of black holes. It will have millions of children, passing on its star-friendly physics to the next generation. Over eons of cosmic time, the multiverse fills up with universes that are optimized for reproduction. This explains the fine-tuning without any need for a designer. Why are the constants of nature so perfect for stars and chemistry? Because we are the descendants of a long line of successful breeders. We are the winners of a cosmic evolutionary tournament. The silent architect is Darwinian evolution operating on the scale of galaxies. The precision we see is not the hand of God. It is the result of billions of generations of trial and error, where the broken universes died in the dark, and the fertile universes inherited the void. We are not special. We are just fit. The theory of cosmological natural selection forces us to swallow a bitter pill regarding our own importance. For centuries, religious and philosophical thinkers have argued that the universe is fine-tuned for life. We look at the carbon in our cells, the water in our oceans, and the light of our sun, and we assume that these things exist to support us. We assume we are the point of the exercise. But Smolin's theory flips this logic on its head. In biology, a chicken is often described as an egg's way of making another egg. The bird itself is just a temporary vessel, a survival machine built to ensure the transmission of genetic material. If we apply this to the cosmos, the egg is the black hole. The universe's goal, if it can be said to have one, is to produce as many black holes as possible to ensure its lineage survives in the multiverse. So where does life fit in? It turns out that the conditions required to make black holes are almost identical to the conditions required to make life. To make a black hole, you need a massive star. To make a massive star, you need huge clouds of gas to collapse under gravity, but gas clouds get hot as they collapse, and the heat creates pressure that pushes back, stopping the star from forming. To get the star to form, you need a coolant, something to suck the heat away. The best coolant in the universe is carbon monoxide. This means that a universe optimized for reproduction must be rich in carbon. It must produce massive amounts of heavy elements, and once you have a universe filled with carbon and heavy elements to cool the gas clouds, biological life becomes an inevitable chemical side effect. We are not the purpose of the universe, we are the mold growing on the reproductive machinery. We are the industrial waste of star formation. The universe does not care about us. It cares about the massive stars that will eventually die and become singularities. We just happen to inhabit the same habitable zone as the parents of black holes. If this theory is true, we should be able to verify it by looking at the numbers. Is our universe actually good at making black holes? Or is it just mediocre? If it were designed for life, we might expect it to be safer. Less radiation, fewer asteroids, more stable stars. But if it is designed for reproduction, it should be a factory of singularities. When we survey the cosmos, we find that it is surprisingly efficient at this specific task. The parameters of nuclear fusion are set precisely to allow stars to burn through their fuel and collapse. If the neutron was slightly lighter, stars would burn too slowly and never explode. If it were heavier, they might not burn at all. The universe seems perfectly calibrated to maximize the number of stellar corpses. Consider the sheer number of them. In the observable universe alone, there are estimated to be 40 quintillion black holes. That is 40 billion. And that number is growing every day as more stars die. This is a staggering rate of production. If you walked into a factory and saw 40 quintillion chairs and one single pile of sawdust, you would not conclude that the factory was built to make sawdust. You would conclude it was built to make chairs. We are the sawdust. We are the accidental complexity that arises on the surface of planets orbiting the engines of creation. The fact that we can think, feel, and wonder about our origin is irrelevant to the cosmic imperative. The universe is a machine for turning hydrogen into holes in reality, and we are just watching the gears turn. This evolutionary perspective also solves the probability problem that haunts the fine-tuning debate. Critics often ask, what are the odds that we are in the one universe that allows life? But under natural selection, this is the wrong question. The right question is, what kind of universe is the most common? If universes reproduce, then after billions of cosmic generations, the multiverse will be dominated by the most fertile lineages. The freak universes, the ones with broken laws or no stars, will have died out long ago. The population of the multiverse will follow a bell curve, where the vast majority of realities are nearly identical to the most efficient breeders. This means we are not winning a lottery. We are simply average. We find ourselves in a universe with these specific laws because these laws are the bacteria of the cosmos, the most successful, widespread, and robust form of physical reality. We are the norm. This removes the mystical aura from the constants of nature. They are not sacred numbers chosen by a deity. They are the standard operating parameters of a successful species. The beauty of the night sky is not a unique masterpiece painted for us. It is a generic template, repeated trillions of times across the bulk of hyperspace, simply because it works. It is the cosmic equivalent of a franchise. We are eating at the McDonald's of the multiverse, mistaking it for a Michelin star restaurant because we have never seen anything else. But evolution is not just about reproduction. It is about competition. In the biological world, species compete for resources, for territory, and for survival. If universes are biological entities, do they also fight? This leads to the terrifying concept of predatory universes. In the landscape of the multiverse, space itself might be the limited resource. A universe that expands faster and more aggressively might overtake and consume its slower neighbors. We see hints of this violence in our own physics. The concept of false vacuum decay suggests that a region of space can suddenly drop to a lower energy state, creating a bubble that expands at the speed of light, rewriting the laws of physics inside it. If our universe collided with another universe possessing different laws, it would be a cosmic cataclysm of unimaginable proportions. One set of physical laws would likely override the other. The stronger vacuum would consume the weaker one. This suggests that the multiverse is not a peaceful garden of isolated bubbles. It is a jungle, a dark forest where universes expand aggressively to secure their existence. Our own accelerating expansion, driven by dark energy, might be an evolutionary adaptation, a defense mechanism to push our boundaries outward as fast as possible to prevent being eaten by a neighbor. We might be living inside an aggressive, invasive species of space-time that is actively colonizing the void. The silence of the cosmos might be the silence of a predator that has already cleared its territory. Cosmological natural selection is a powerful theory. It explains the fine-tuning, the abundance of black holes, and the eerie precision of our laws without invoking magic. But like the alien zoo hypothesis, it suffers from the problem of the beginning. Evolution describes how things change over time, but it does not explain how the process started. In biology, we can trace the tree of life back to the first simple cell. But where did the first cell come from? It came from chemistry. And where did chemistry come from? Physics. In the cosmic version, if our universe is the child of a previous universe, and that one is the child of another, we can trace the lineage back through eons of time. But eventually, we must arrive at the first universe, the original ancestor, the Adam of the multiverse. Where did that universe come from? It could not have evolved, because it had no parent. Did it appear by random chance? If so, why did it have the capacity to reproduce? Why did it contain the machinery of black holes and singularities? The evolutionary explanation collapses when we reach the bottom of the timeline. We are left staring at the same mystery we started with. This forces us to dig deeper. We must peel away the biological skin of the theory and look at the skeleton underneath. Biology is messy, wet, and changing. But reality seems to be built on something rigid, eternal, and absolute. Something that does not evolve because it is perfect. We are leaving the messy world of the flesh and entering the crystalline world of mathematics. The silent architect might not be a parent or a predator. It might be a shape. When we look at the universe through the lens of evolution, we see a world of change, adaptation, and messiness. Biology is squishy. It is defined by accidents, mutations, and the struggle for survival. But when we drill down to the bedrock of reality, to the fundamental laws that allow biology to exist, we find something that is the exact opposite of squishy. We find something cold, hard, and terrifyingly precise. Consider the electron. Every single electron in the universe is exactly the same. They all have the exact same mass, the exact same charge, and the exact same spin. There is no evolution of the electron. There are no mutated electrons that are slightly heavier or slightly lighter. They are identical, manufactured to a tolerance of 0. This uniformity does not look like biology. In biology, variation is the rule. In physics, variation is forbidden. This rigidity suggests that the living universe theory, while compelling, is only describing the surface layer. It describes the skin of the cosmos, but not the skeleton. Underneath the chaotic foam of reproducing universes and black holes, there must be a rigid structure that defines what an electron is. There must be a framework that holds the constants in place before they can mutate. We are looking for the absolute bottom of the well, and at the bottom, we do not find a parent, or a god, or a cell. We find a structure that is eternal and unchanging. We find the only thing in existence that cannot be destroyed: geometry. This brings us to one of the deepest philosophical mysteries in science, famously articulated by the physicist Eugene Wigner as the unreasonable effectiveness of mathematics. Why do numbers describe the universe so perfectly? We invented mathematics to count sheep and divide land. It is a language of the human primate. Yet, when we use this language to describe the collision of black holes or the vibration of subatomic particles, It works with a precision that borders on the miraculous. We can write down an equation on a piece of paper, solve it for x, and then look up at the sky and find a planet exactly where x said it would be. We predicted the existence of the Higgs boson using math 40 years before we built the machine that found it. This implies that mathematics is not just a description of reality, it is reality. The theory of mathematical Platonism suggests that the physical world is a shadow cast by the mathematical world. The triangle you draw on paper is imperfect, but the concept of the triangle is perfect and eternal. In this view, the silent architect is not a person or a process, it is a truth. The universe is fine-tuned because it is a physical manifestation of a perfect mathematical object. We are living inside an equation, and unlike a biological organism, an equation does not care if you live or die. It simply is. It is the ultimate cold shoulder, a structure of infinite beauty that exists entirely for itself, with us as mere dust motes floating in its geometry. But what does this equation look like? If the universe is a shape, what is the shape? One of the most beautiful and controversial proposals comes from the physicist Garrett Lisi. He suggests that the fundamental structure of reality is a geometric object known as E8. E8 is a multidimensional crystal. It exists in 8 dimensions and has 248 points of symmetry. It is unimaginable to the human brain, which is stuck in 3 dimensions, but mathematically, it is the most beautiful and complex structure known to exist. Lisi realized that if you rotate this crystal in 8-dimensional space and look at the shadows it casts on our lower reality, those shadows match the fundamental particles of physics. Turn the crystal one way and you see an electron. Turn it another way and you see a quark. Rotate it again and you see a neutrino. This theory suggests that the bewildering zoo of particles, the muons, gluons, and bosons, are not separate things. They are just different facets of the same object. The universe looks complex to us only because we are seeing it from a limited angle. If we could zoom out and see the whole crystal, we would see a single, perfect, static jewel. In this model, the fine-tuning of the universe is inevitable. The constants of nature are determined by the geometry of the E8 lattice. An electron weighs what it weighs because of the angle of the facet. Gravity is weak because of the shape of the curve. There is no tuner. There are no knobs. The universe cannot be any other way, just as a circle cannot have corners. The perfection we admire is the perfection of a diamond. It is flawless, it is unbreakable, and it is completely indifferent to the light shining through it. If the E8 theory feels too speculative, there is a more recent discovery that is accepted by mainstream physics, and is even more mind-bending. It is called the amplituhedron, discovered by Nima Arkani Hamed. For decades, physicists calculated the particle collisions using Feynman diagrams, complex drawings that assumed particles move through space and time. These calculations were messy, requiring hundreds of pages of algebra. But Arkani Hamed found that the volume of a specific geometric object, a multi-dimensional jewel called the amplituhedron, gives the exact same answer as the hundreds of pages of formulas. And the terrifying part? The calculation using the jewel makes no reference to space and no reference to time. This implies that space and time are not fundamental ingredients of the universe. They are emergent properties. They are the output of the geometry, not the stage. Think of it like a video game. On your screen, you see a 3D world with time flowing. But inside the computer processor, there is no 3D world and no time. There is only a series of static logic gates processing data. The amplituhedron is the logic gate of reality. It sits outside of time, eternally static, and its geometric properties generate the illusion of now and here. This confirms the suspicion that we are living in a derived reality. The silent architect is a geometric form that sits outside the universe, casting space-time like a shadow. This makes our experience of life feeling profoundly secondary. We are not the inhabitants of the real world. We are the projections of the geometry. The real world, the amplituhedron, is timeless, silent, and abstract. It does not flow. It just exists. The existence of a rigid geometric structure at the heart of reality leads to the most claustrophobic concept in physics: determinism. If the universe is a shape, whether it is E8 or the amplituhedron, then it is a finished object. A shape does not make choices. A shape does not evolve. A shape simply is. This brings us back to the concept of the block universe, but with a new layer of mathematical certainty. If the future is just another part of the crystal, then your life is not a journey. It is a path etched into the diamond. Every choice you think you are making, to watch this video, to lift your hand, to take a breath, was calculated and solidified at the moment of the Big Bang, determined by the immutable angles of the geometry. We feel like we have free will because we cannot see the whole crystal. We are like ants crawling along the edge of a statue, thinking we are exploring a new world, when in reality we are just following the curve of the marble. This makes the universe a prison, a beautiful, perfect, fine-tuned prison. The bars are made of mathematics, and the warden is logic itself. There is no escape, because to escape you would have to violate the geometry of existence. This realization creates a sense of fatalism. It suggests that the fine-tuning is not a gift given to us so we can live. It is the wall of our cell. We fit the universe perfectly because we are carved out of it. We are the negative space in the crystal. And while this guarantees our existence, it strips us of our agency. We are safe, yes, but we are also trapped in eternity, playing out a script that was written in the language of geometry before the first star caught fire. However, even if we accept that the universe is a perfect geometric jewel like the E8 crystal or the amplituhedron, we are left with the deepest question of all. It is the question that haunted Stephen Hawking until his final days. He asked, even if there is only one possible unified theory, it is just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? Think about this distinction. You can write down the chemical formula for fire on a piece of paper. You can describe the oxidation reaction perfectly, but the paper will not burst into flames. The equation describes the fire, but it is not the fire. It lacks the heat, the light, and the consuming power of the real thing. Similarly, the geometric theories describe a universe, but they do not explain why that universe bothers to exist. Why is there a physical world at all? Why isn't there just the silent, abstract mathematics floating in the void? This is the problem of being. Geometry is a plan. It is a blueprint. But a blueprint of a house protects no one from the rain. Something had to take that blueprint and build it out of energy and matter. Something had to breathe fire into the math. The silent architect might be the geometry, but who is the builder? Who pumped the energy into the system to inflate the crystal into a tangible reality? This mystery suggests that math is necessary, but not sufficient. There is an ingredient missing from our theory of everything. An ingredient that transforms abstract possibility into concrete reality. Some physicists argue that the math is so perfect that it forces itself into existence. But this feels like a magic trick. It implies that if you imagine something clearly enough, it becomes real. The alternative is that the fire is a separate substance, a primal energy that fills the geometric mold. And if that is true, then the universe is not just a shape. It is a shape filled with power. And power tends to do something that static shapes do not. It burns. This leads us to a fundamental conflict between the world of geometry and the world of experience. In the crystalline world of E8 or the amplituhedron, time does not flow. The structure is static. It is eternal. Furthermore, the laws of physics derived from this geometry are time symmetric. They work exactly the same way forward and backward. If you play a movie of a planet orbiting a star in reverse, it looks perfectly natural. The geometry does not care about the direction of time, but you care. You care deeply because you are not made of geometry. You are made of matter, and matter does not obey the symmetry of the crystal. If you drop a coffee mug, it shatters into 100 pieces. You will never, ever see the shards leap off the floor and reassemble themselves into a mug. The movie of your life looks very different when played in reverse. We see rot. We see aging. We see memory accumulating. We see a relentless march from the past to the future. This implies that while the shape of the universe might be determined by geometry, the direction of the universe is determined by something else. The crystal provides the stage, but it does not provide the plot. There is a force pushing us through the facets of the jewel, driving us from order to disorder. The universe is not just a statue, it is a machine that is running. And like any machine, it creates friction. It creates waste. It creates heat. This realization brings us to the final and most ruthless suspect in our search for the architect. We are leaving the clean, cold world of mathematics and entering the dirty, irreversible world of thermodynamics. We have arrived at the sixth line, and this is the one that arguably holds the most power over your daily existence. It is the domain of entropy. While quantum mechanics and relativity are the laws of the universe's construction, the second law of thermodynamics is the law of its destruction. And in the long run, destruction always wins. The second law states that in any closed system, the amount of disorder or entropy must always increase. Energy tends to spread out. Structures tend to crumble. Information tends to degrade. It is the only law in physics that distinguishes the past from the future. The past is ordered. The future is chaotic. This law is not a suggestion. It is an ironclad decree. Sir Arthur Eddington famously said that if your theory disagrees with the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation. If we view the universe through this lens, the fine-tuning takes on a grim new appearance. The universe started in a state of incredibly low entropy. The Big Bang was a moment of supreme order. Ever since then, it has been sliding down a slope toward chaos. The stars, the galaxies, and the planets are not permanent features. They are just temporary eddies in a river that is rushing toward a waterfall. This shifts our understanding of perfection. The universe is not fine-tuned to create. It is fine-tuned to decay. The laws of physics allow for complex structures like stars only because stars are excellent at converting concentrated energy, nuclear fuel, into scattered energy, heat and light. The universe allows creation only because creation is a messy process that ultimately increases the total amount of disorder. We are not building a kingdom. We are burning a candle. And the laws of nature are simply the wax that keeps the flame alive for a little while longer. But if the universe is relentlessly marching toward chaos, how do we explain us? Look at a human body. It is a masterpiece of order. Trillions of cells working in synchronization. DNA coiled with mathematical precision. Neurons firing in organized patterns. We are low entropy objects. According to the second law, we shouldn't exist. We should have dissolved into a soup of random chemicals billions of years ago. This is the paradox that Erwin Schrödinger explored in his famous book, What is Life? He realized that life is something that actively resists the decay of the universe. A rock left in the sun simply heats up and crumbles. It accepts the entropy. But a plant takes the sunlight and uses it to build complex sugar molecules. It creates order out of chaos. A living thing is an island of structure in a sea of disorder. This makes life look like a rebellion. It feels like we are fighting against the architect. Like we are cheating the laws of physics by staying organized. We cling to life, repairing our cells, eating food to maintain our structure, holding back the tide of rot. This perspective creates a heroic narrative. Life versus the universe. We are the underdogs fighting a cosmic war against death. But recent discoveries in non-equilibrium thermodynamics suggest that this narrative is completely wrong. We are not fighting the universe. We are doing its dirty work. In 2013, the biophysicist Jeremy England proposed a radical new theory known as dissipative adaptation. He argued that life does not violate the second law of thermodynamics. On the contrary, life is the most efficient way to obey it. Think about a star shining on a sterile rock. The rock absorbs some heat and reflects some light. It increases the entropy of the universe slightly. Now think about a star shining on a forest. The trees absorb the light, use it to grow leaves, and then radiate heat into the atmosphere. The biological processes, photosynthesis, metabolism, respiration, are incredibly messy. They generate a massive amount of heat. In fact, a living planet produces entropy far faster than a dead planet. England showed mathematically that if you bombard a clump of atoms with energy, like sunlight, the atoms will spontaneously self-organize into complex structures if those structures are better at dissipating the energy. Life is not a lucky accident. It is a physical necessity. Matter organizes itself into bacteria, plants, and humans because organized matter burns energy more efficiently than disorganized matter. This is a shattering realization. We are not rebels, we are heat engines. The universe wants to reach a state of heat death, total equilibrium, as fast as possible. But it's hard to burn up all the energy in stars just by letting them shine. So, the laws of physics are fine-tuned to allow the emergence of complex life. We are the catalysts. We are the fire accelerant. The silent architect created us not to nurture us, but to use us. We are beautiful, complex, and intelligent only because those traits make us better at destroying order. We are the universe's way of committing suicide more quickly. This theory transforms our understanding of the so-called Goldilocks zone. We usually believe that the Earth is situated at the perfect distance from the Sun to nurture us, like a mother keeping her child warm. But under the lens of dissipative adaptation, the relationship is far more predatory. The Earth is not a cradle, it is a furnace. The universe places planets in these zones because that is where the energy gradient is steepest. That is where the potential to do work is highest. And nature abhors a gradient. It wants to flatten the curve, to mix the hot and the cold until everything is lukewarm. By evolving complex life, the Earth has become a machine that devours sunlight and spits out infrared radiation with frightening efficiency. We are the catalysts. In chemistry, a catalyst is a substance that speeds up a reaction that would otherwise take forever. We are the enzymes of the cosmos. Without us, the sun's energy would hit a dead rock and bounce off, degrading slowly. With us, that energy is captured, processed, metabolized, and scattered into the void at a much higher rate. The fine-tuning of the physical constants, the strength of the carbon bond, the fluidity of water, the reactivity of oxygen, is essentially the tuning of a combustion engine. The universe has calibrated its parts to ensure that the fuel, life, burns as hot and as fast as possible. This is the golden trap. We were lured into existence by the promise of consciousness and joy, but our physical purpose is simply to help the universe die. We are the wood that thinks it is special because it is being used to build a fire, never realizing that the fire's only purpose is to turn the wood into ash. The architect is not a gardener. The architect is an arsonist, and we are the matches. If we are the matches, what does the ash look like? To see the final masterpiece of the architect, we must look to the deep future, the heat death. This is not a violent apocalypse. It is the slow, agonizing fade of all possibility. As entropy maximizes, the universe enters a state of thermodynamic equilibrium. The stars burn out. The black holes evaporate. The atoms decay. The temperature of the cosmos drops to a fraction of a degree above absolute zero and stays there forever. In this state, time loses its meaning. Time is a measure of change. It is the ticking of a clock, the beating of a heart, the orbit of a planet. But in the heat death, nothing changes. There is no flow of energy to drive a clock. There is no gradient to push a piston. The universe becomes a stagnant ocean of cold photons, stretching out into an infinite, expanding dark. It is a portrait of perfect, sterile symmetry. This is the ultimate answer to the question, why is the universe fine-tuned? It is fine-tuned to ensure that this silence happens. Every law of physics, every constant of nature is driving us toward this specific destination. The geometry of space, line 5, provides the container. The holographic code, line 3, describes the state, and the engine of life, line 6, speeds up the arrival. The silent architect is silence itself. The universe emerged from the void, danced a brief, violent dance of complexity, and is now rushing to return to the void, but with the added burden of infinite entropy. It is the great winter that never ends, a statue of ice carved from the fires of the Big Bang. When we step back and look at the spiral we have climbed, the separate lines of inquiry, the quantum loops, the alien labs, the holograms, the living universes, the geometric crystals, and the entropy engines, begin to merge into a single, coherent, and terrifying shape. We thought we were looking at different theories, competing explanations for why reality is the way it is. But they are not competitors. They are layers of the same machine. The fine-tuning is simply the result of all these systems working in unison. The universe is perfect because a machine that doesn't work doesn't exist. We are looking at the survivor of a logical selection process. We are the ghost in the machine, wandering through the circuits, marveling at how well the wires are insulated, not realizing that the insulation is there to keep the machine running, not to keep us comfortable. The puzzle is solved, but the picture it reveals is not a portrait of a loving father. It is a schematic of a furnace. So, who is the silent architect? We started this journey looking for a face. We looked for the face of God, the face of an alien, or even our own face in the mirror. But the face we found is blank. The architect is not a person. It is not a conscious entity that makes decisions or feels love. The architect is necessity. It is the blind mathematical force that dictates that if a universe exists, it must follow the path of least resistance. It must satisfy the equations of geometry. It must obey the second law of thermodynamics. The intelligence we see in the laws of physics is not wisdom. It is the sheer, brute force of logic. Gravity pulls because it has to. Atoms bond because they have to. We live because we have to. This realization strips the universe of its romance, but it also strips it of its malice. The universe is not trying to kill us, nor is it trying to save us. It is simply solving an equation. We are the variables that balance the formula. This is the God of Spinoza that Einstein believed in. A God that is identical to the order of nature, cold, beautiful, and completely indifferent to human prayer. Accepting this is the hardest step. It means accepting that we are orphans in a house of infinite grandeur. There is no one coming to save us. There is no one watching the experiment. There is only the hum of the machine and the slow ticking of the clock as the energy runs down. If we are trapped in a machine designed to destroy us, if our lives are predetermined by geometry and our purpose is to be fuel for the entropy, what is left? Do we lay down and die? Do we succumb to the nihilism that says nothing matters? The French philosopher Albert Camus faced this exact question. He compared the human condition to the myth of Sisyphus, a man condemned by the gods to roll a boulder up a hill for eternity, only to watch it roll back down every time. It is a pointless, hopeless task. It is the definition of absurdity. Our universe is the hill. Entropy is the gravity that pulls the stone down. And we are Sisyphus, building our civilizations, writing our songs, and loving our children, knowing that eventually the heat death will erase it all. But Camus argued that we should not despair. He said, "One must imagine Sisyphus happy." Why? Because the struggle itself is enough to fill a man's heart. The very act of pushing the stone is a rebellion against the absurdity. By acknowledging the truth that the universe is cold and indifferent, and choosing to live anyway, we become greater than the universe. The universe crushes us with matter, but we conquer it with meaning. We create value where there was none. We light a fire in the void, not because it will last forever, but because it defies the dark right now. This is the revolt. It is the refusal to be mere sawdust. It is the decision to be a witness. This act of witnessing is more precious than you can possibly imagine. We often complain that life is short, but we rarely realize how short the life of the universe is. I don't mean the total lifespan of the cosmos. That is effectively infinite. I mean the lifespan of the light. We live in the stelliferous era, the age of stars. It is the only time in the history of the universe when stars are burning and galaxies are bright. But on the logarithmic timeline of the cosmos, this era is a flash. It is a fraction of a percent of the total timeline. Before us was the dark chaos of the Big Bang. After us is the eternal night of the black hole era and the dark era. We have woken up in the single briefest window of opportunity. It is like waking up during a fireworks display that lasts for 1 second in a year of darkness. The fact that you are here, with a brain complex enough to understand the physics of your own extinction, sitting on a planet that hasn't yet been swallowed by its sun, is a statistical miracle that makes the fine-tuning of the constants look like a coin toss. We are the guardians of the light. We are the eyes of the universe during its one moment of clarity. This makes every second of your consciousness the rarest resource in existence. To waste it on boredom or hatred is a crime against the probability that allowed you to exist. And what do we do with this time? We observe. In a universe governed by the destruction of information, consciousness does something radical. It preserves it. When you learn a fact, when you remember a face, when you understand a theory, you're creating a local reversal of entropy. You are taking the chaotic data of the world and organizing it into a coherent structure inside your mind. For a brief moment, the universe remembers itself through you. We are the librarians of the cosmos. We collect the stories of the stars before they burn out. We calculate the age of the singularities before they evaporate. We map the geometry of the crystal before the lights go out. Even if the library eventually burns down in the heat death, the fact that the books were read matters. This connects back to line 1, the observer. We may not have created the universe retroactively, but we are validating it presently. Without us, the universe is just a tree falling in a forest with no one around. It makes a vibration, but it makes no sound. We are the sound. We are the color. We are the meaning. We are the glitch in the mechanism that allows the machine to feel its own operation. This is not a scientific function, it is a sacred one. It justifies the entire 14 billion year struggle of evolution. The universe built a trap, yes, but the trap caught something beautiful. So let us return to the image of the candle. A candle is a fine-tuned object. The wax must be the right consistency. The wick must be the right thickness. The oxygen must be the right concentration. If you looked at a candle without knowing what it was, you might think it was designed to stand there forever, perfect and pristine. But the purpose of the candle is not to exist. The purpose of the candle is to burn. The universe is that candle. The fine-tuning of the constants, the geometry of the E8 crystal, the biological machinery of evolution, it is all just the wax and the wick. And we, life, consciousness, observation, we are the flame. A flame is a violent, destructive process. It eats the wax. It turns potential energy into waste heat. It obeys the laws of thermodynamics perfectly. But in doing so, it creates light. It pushes back the darkness. It creates a circle of warmth where things can be seen and understood. We are the flame of the universe. We are consuming the future to create the present. And yes, the candle will eventually burn down. The wax will run out. The flame will flicker and die, and the smoke will drift into the eternal night. But that does not mean the flame was a mistake. It means the candle did what it was supposed to do. The question we started with was, who created the universe? We looked for a god, a programmer, an alien, or a mutated black hole. We looked for a silent architect. But the truth is more intimate. The universe was not created for us, and it was not created by us. The universe is us. We are not separate from the geometry. We are not visitors in the laboratory. We are the atoms of the universe that have woken up. We are the way the cosmos knows itself. The silent architect is the fundamental nature of reality unfolding through time. And for this brief, shining moment, that architect has opened its eyes and looked in the mirror. And the face in the mirror is yours. This is the ultimate resolution of the fine-tuning paradox. The universe fits us perfectly because we are not a foreign object put into a box. We are the shape the universe takes when it becomes complex. We are the wave cresting on the ocean of math. The wave cannot be separated from the ocean, and the ocean implies the wave. You are the universe's way of being alive. So, do not look at the fine-tuning of the cosmos with fear. Do not look at the black holes with dread. Look at them with pride. You are the only thing in this vast, cold machinery that can feel the wonder of it all. You are the victory of the unlikely over the impossible. If this journey through the layers of reality has made you feel small, let that smallness be a comfort. You don't have to carry the weight of the universe. You just have to watch it. You just have to be the flame. This channel is dedicated to asking the questions that keep us awake at night. We don't settle for the easy answers. We dive into the math, the madness, and the mystery. If you want to join us on the next expedition into the unknown, where we will tackle the paradox of consciousness and the possibility that death is an illusion, then make sure you are subscribed. The universe is vast, and we have only just scratched the surface.